Let's review what I've learned so far. Up to now, we've covered how this ReLU stack, linear ReLU stack, is created and what happens within this stack on the last video. So after that, I've done a deep dive into this flatten class, and we're getting an instance of this class here and applying to flatten. And then here in forward, we're using that instance to flatten the tensor we pass in. So we will look at this flatten method, right? So if I go into it, what it tells me here is basically flatten a contiguous range of dimension into a tensor for use with sequential. So it's specifically used with the sequential class we're using in our code we looked at previously. And what it requires is it wants the starting dimension to flatten and the end dimension to flatten. So for example, if we flatten a input which is 32 by 1 by 5 by 5, then when we flatten it, we can see the result. The size of that becomes 32 by 25. So it does 5 by 5 and gets that, and then it removes this particular dimension. And if we provide if we provide how to flatten it, then it flattens everything and just gives us 160 by 5. Now, if we look at the code here, I think there is a part where we have the image. So for example, and flatten says we initialize and flatten layer to convert 2D 28 by 28 image into a contiguous array of 784 pixels value. The mini batch dimension at dimension 0 is maintained. So the first batch is the dimension, which is this, and so it was 28 by 28, therefore we got 784 in one dimension, 784 items, right? So the 28 by 28 is basically what it is like we are using grayscale images here, but let's just look at a colored image, right? So I've done a bunch of, so I got this torchvision.io to read the image, and I have this, so I got torchvision to read the image. I have torchvision.io.image, and image read mode is to define the read mode to force it not to read the alpha channel. So when you read an image, usually we have 3 channels RGB, but you can also end up getting the 4th channel, which is the alpha channel. That basically tells you the opacity of the image of each pixels. And so here I'm reading that with the image read mode 3. So if we look at the image read mode code, image read mode, so here it says supports various modes while reading images. Unchanged for loading image as is, image read mode gray for converting to grayscale, RGB for RGB, and RGB alpha for RGB with alpha, which provides us the 4 channel, right? So, and then if we look into the reason I'm showing you this is when we do flatten, it will keep this. So we have 3 layers and we have 258 by 303. Now, usually these are referred to as height and width, but which I find a little bit confusing, because what they represent, the numbers represent the height and width, but what's inside is actually the full image data, right? So if you look at, how do we look at this? So let me see if I can open a PyCharm here. So if we look at we look at a file, let's just create a new Python file. And if we just have examples, right, and then if we just add a list here, let's pretend that it's a tensor for the example region here. So we have three, this is the main tensor, let's just call it a tensor. And within this, we have three channels, okay? And within this three channel, we have how many numbers? 258 by 303. So for this first channel, we have 258. So the items like that, we have 258 of them, right? If that makes sense, and so on, right? Within these 258 items, we have 303 elements, let's say, or item in a tensor, 303, right? So let's just say, so these will be 0 to 1 decimal numbers, so we can just say 0 0.1, 0 0.11, 0. Whatever, it's just random, right? So I'm just gonna copy paste that, and there we go. So we have that. That's basically the structure. So don't, when you read into this and you look at a shape, yes, the shape does refer to the width and height of an image, but it does that by having this array or the tensors in tensors of PyTorch. So you have this complex data structure here, or nested, you can say, that holds that contains the information, which is the image, right? So when we flatten these things, that's what we're doing. We're not losing the information, we are losing this dimension complexity. So we are reducing the dimension complexity, right? So we get to something simpler in dimension wise. But here we don't have channels because we're just using grayscale. So these channels are red, green, and blue, as you can see here. I have so let's just go through this. So I read the image without the alpha channel. Then what I'm doing here is I'm showing you the shape of the image, and here we're using this permute. The reason we're using this permute thing is basically how Torch tensor records an image and how matplotlib, this plt.im show, this method, how it wants the image structure to be to visualize it in the screen are two different things. So which is why we need to permute the tensor to show it correctly using the plot.im show method, right? And the permute method does not actually change anything in the tensor. It just changes how we view the tensor. So it does not actually copy or create a new variable. And actually I want to deep dive into that and understand how they achieve that, because that sounds very tricky. But that's what permute does. It just gives us a view into the tensor, right? So that's why I was able to draw that here. And you can see here when I do the full permute and show the image, we can see the whole image. But then when I have the so what's this here, let's check. This is red, so we have red on, and this is green, and this is blue, right? So you can see, and the last one is because it's how the image is, right? So it sort of appears on every single channel because it has all the colors, so it sort of fits into every single one when we show it. And now because this is a colored image, you can see the image has three channels, and each channel has that that complexity we just talked about, which is the dimension, right? The shape. Now the image we are using are a grayscale, which is why they're just 28 by 28. So when we actually flatten, that's what we are flattening. We're not flattening the batch size, we're flattening the each image data. So hopefully that makes sense. and hopefully what I'm explaining is correct. To be honest, I think it is correct because I've deep dived into all those details, and yeah, that's what I've learned so far in the flatten space, right? So flatten and how it works and why we do that. And lastly, I just want to quickly touch on this, but we will go through it on the next video. So here, if we go back to build the network and the code, and here what we do is, like it says, we don't actually call the forward method, PyTorch does, but we have a code here which basically, so we have an instance of this class here, and we pass our x input into the input tensor into this flatten. We have the flatten input tensor here, and then now we pass that into our linear ReLU stack, which is this stack. And when the neural network does all the forward pass and backward pass, we get the logits. Now the logits are the output of the network, but they are just output tensors. We need to convert them into probability distribution using softmax, which I'll cover and discuss in detail in the next video, what I've learned so far. But I feel like I'm making a good progress so far, and really, yeah, enjoying the learning of it. Hope you are also learning neural network at the moment. Feel free to share your thoughts on the comment section below. And yeah, subscribe if you like these videos and you want to continue watching them.